Hello, and welcome to Lesson 1 in a series of videos about water supply and flow ecology modeling with the WOOOMM system. This lesson will take you through the basic steps of creating and saving a project and running a basic water supply simulation. The first thing you need to do is log into the system. So here I'll enter my username and my password, hit submit. Wait a second as the interface loads. When the interface loads, after logging in, you see you're presented with a tab called the Project Browser. This shows you projects that you've already created. I have none available because I've created none. Groups, projects, that means projects and other folks that are in your group. There are none there. And then there are also some public projects. If you've been a user for a while, you're part of groups, you would see multiple projects here in these two things. But for now, let's get started and create a project. So we click on the New Project link and then wait a moment as the system populates our project with some default values. Okay, so it starts out, first thing you want to do is give your project a name. I'm going to call this my water supply model. I'm going to select the type of water supply. I'm just going to select that as a main stem riverine impoundment, which means I'm going to simulate a water withdrawal that's coming off the main stem of my modeling segment, and then I'm going to call this description of a testing model. Now, in addition to naming your model, which is important to make it distinct for you and the folks that you're working with, you also want to select a location. Now, the models come preloaded with a stock location, but I'm going to go ahead and put in my own latitude and longitude for my withdrawal point. And I'm going to choose a latitude and longitude that I know will leave me somewhere in the Roanoke River drainage. Okay, so once you've entered your latitude and longitude, you'll see down here under Select Best Model Locations, a few radio buttons giving you some options for watersheds that you might simulate. Okay, I'm going to simulate the larger VAHydro main stem segment, instead of these two NHD plus segments. And if you tune into a later tutorial, you'll get to see some information about what these options mean. But for now, we'll just choose the first one. Okay. I'll also note that this is 380 square miles in drainage, as it's saying, and we need to set our project drainage area to some number that represents how far along the watershed our point is. I'm going to make it equivalent to this number here, which means that I'm simulating a withdrawal right at the outlet of this watershed. Okay, now that I've selected my location, my size, and the particular modeling subsegment that I want to look at, I'm going to go ahead and save this. All right. Saving it may take a few seconds, particularly the first time you save it, because it has to initialize a number of things in the modeling. Probably takes about 30 seconds all in all. Okay, now our model has been saved. It said that we've done that, and we're going to go to our next step. And this is now all we need to do is go ahead and run the model. Okay, so there are three pieces of information that you need to submit to start a run model, but only one of them will really do on detail right now. First thing, the base model scenario. We're going to leave that at the default values here. Second thing is our model time span. I'm going to select a short time span here. I'm going to say 1999. All right, I'm going to go from October 1st, 1999 to October 31st, 1999. So just doing a 1 month simulation in order to be quick about it for this demo. And then store results as run ID. Okay, the default value is this none -1, and I'm going to leave it at that as well. All right, so we click run model, and then we see down in our model window, model run requested contacting server. Some other debugging information that gets set out there for you, but we don't have to pay attention to that. But just note that anytime that the model server is running, you just can click update model status, and it'll tell you where on the simulation it is. So right now it's in the initialization status. It takes about 30 seconds for it to initialize any model, and then it will take about 30 seconds per year of simulation in order to run that model. So you just be patient. Occasionally check back on update model status to see where you are, and wait for your simulation to complete. check our status again. Looks like we're about halfway through our simulation. As I said, that'll complete very rapidly once it gets going. Check again now. We're finished post-processing. So once we've finished, gotten the message that our model is finished, in order to check the results of our model, we'll go over to our Results and Analysis tab. Now, first thing you'll see when you get to that Results Analysis tab is there is no recent model run log file for this object. So since we just ran the model, we're going to go ahead and ask to refresh our list. So we refresh that list, and now we see that -1 scenario is selected. That's what we ran this as result ID -1. We now have -1. We hit refresh again, and it will load our model data. And then if we scroll down here, you can see we have the date in the first column, and it says our local channel Q in. So that shows our inflow, it shows our local channel Q out, shows our outflow, and then any withdrawals in that reach. As you see in this particular instance, we haven't really set any withdrawals because it's a very simple simulation. Okay, well, so now you've gone ahead and seen how to set up some basic things about the model, locate that model in space, how to run the model, and how to do some of the very, very rudimentaries of displaying your model analysis. There's a few other pieces of information that come out, but we'll save looking at that at a future lesson. So that's it. I hope you enjoyed. Thank you.